Once again, welcome everyone to Neuton Maker Day. It's actually the first time when we're doing this event in this particular format. And today we will be happy to present you 5 TinyML projects developed by our ambassadors, and they will be presenting it with the details. You will have opportunity to ask your questions. And after that, we will have a award ceremony when you will choose the best project of today. And this project will be awarded, and the author, the developer, will get the prize from Arduino. And also we have a lot of prizes from our sponsor Pact. So we have prizes for our makers and also for our attendees who are joining us today. So be here, please, and stay till the end, because we announced challenge. So the first part of this challenge was to submit your idea of project, and for the best ideas, we will give you and we will award you by very, very trendy books about IoT, about IE embedded technology. So stay till the end to get your prize. And then after this ceremony, we will announce the second part of our challenge that will start today. And the prize will be also the board from Arduino. Okay. With this, I'm finishing, and I give micro to Jan. Please start our Neuton Maker Day. All stage for you.
Thanks so much, Julia, and welcome to everyone who is attending the Maker Day from Neuton today. As Julia mentioned, we've got 5 different talks all on no-code IoT implementations that you can do through Neuton. Just before we begin, very briefly, in case you don't know who I am Ian. I am the host of the Electromaker show on the Electromaker YouTube channel. It is a weekly show about maker and embedded culture. The site of Electromaker as well is a project hub. We have a large community, and in fact, all of the projects you're going to be seeing today are published on the Electromaker website. We also do things like competitions. In fact, we've just started a PCB-based competition where you can get a PCB fabricated for free, and the thing that you make with it can win you up to $1,000 in cash. Anyway, today is not really about Electromaker. I just wanted to give you context as to why I'm here, but I'd like to begin by saying thank you so much for asking me to host this. It's a very great opportunity. As Julia has already mentioned the agenda, there's one thing I just wanted to mention is there will be the option of a Q&A with each one of our speakers as we go through. However, just for time constraints, what we're going to do is collect the questions and we'll have one of them answered live. However, after the fact, every single question that is asked about every project will be answered. It might just be something that we do after the fact just to keep this thing not going on far too long. And before we go through each one of our presenters, I just want to very briefly explain who they are and why they are here. So Sumit Kumar will be our first speaker. He'll be talking about predictive maintenance of compressor water pumps. And there's a lot I will be saying very soon about Sumit. But for someone who's just 18 years old, he's someone who has already achieved quite a lot. You'll also be hearing from Leonardo Cavenice, whose name I'm hoping I just pronounced correctly. And he's going to be showing you a slope control project for robots using Arduino Pro. Yeah, he's a passionate firmware engineer with a focus on IoT and various other systems. You'll also be hearing from Timothy Melcher, whose smart shipment system can determine exactly how a parcel is moving, not just where it is, but how it's being treated. And you're also going to hear from Rukshika Rajkumar, who has made a tic-tac-toe game into something a lot smarter by using digit recognition and a touchscreen on an M5 stack board. And finally, you'll be hearing from Leonardo Gonçalves, who will be showing you how you can predict the winner of the F1 race, which sounds like quite a large project, but it is actually surprisingly simple with the right tools. So with that being said, let's get on with our first presentation. So, as I previously mentioned, Sumit Kumar is someone who has achieved quite a lot for someone who's just 18 years old, and you're about to see his predictive maintenance of compressor water pumps project. And this is in fact a short video of it in action. So what you are seeing there is obviously a water pump in situ with an embedded and tiny ML featured project attached to it. And without any further ado, I'm going to hand you over to Sumit to explain his project.
Thank you, Jan. I hope you can see my screen.
Yep, looks good.
Yeah. So today we are going to talk about this project called as predictive maintenance of compressor water pumps. And in this project, we are going to learn how we can use sensors and data to detect trends in the health of the system and predict the failure before it occurs. So this type of system actually detects the deterioration of a machine before the maintenance team takes more time to predict it or just maintain the failure events. So why do we need this? So to understand this, we need to go in depth the problem statement that actually becoming the story of this project. So actually I live in Jharkhand state of India, and here the problem is like water in some places you don't have proper access to water, and you use all these compressor pumps to lift water so that you can use it in your homes for all the daily works. So sometimes what happens is like whenever there's a fault in your pumps, you have to wait certain weeks as well to get it repaired, to get it fixed. So that is a bad thing, and it's like a severe issue actually, because you have to wait without accessible water for days. So how to fix that problem? So we are going to talk about how different type of maintenance are there and how we can troubleshoot the issues before it becomes more severe. So to understand this, we are going to talk about the main difference. So main difference is you just need to understand the dependence on data. Now it's time for predictive maintenance. It means that you're going to rely upon the sensors data to tackle the events that are going to come in future. And you can avoid a lot of unexpected machinery issues with this. So this is going to be a good strategy for anyone who is going to apply it to industrial solutions, and how we can make it easily fixable. And the downtime cost is actually very low here. The downtimes are not going to be very costly here. So that's the main focus. Now there are a few downsides as well of this predictive maintenance, that it's require huge budgets, and that is all of the downsides. And sometimes there is also like false triggers. So that is also one of the downsides, but that can be ignored in long run. And this is a actually evolving scenario here. So we are going to learn how we can deploy this on industry's smallest sensor, that is RSL10 from ON Semiconductor and Bosch. And this is a powerful board actually, which has got lots of features and a powerful processor. And with that, it comes with a 10 years battery operation on deep sleep mode. It means your industrial machines can run these tiny ML things for a long time, and you can deploy in batches, or you can say for your whole industry units. So it also got wireless features, and as you can see, as the industry like the ON Semiconductor mentions, it has got a lot of power features for you long lasting, as well as for connecting deep devices into one grid. So let's talk about sensor fusion. What is it and how we are going to use it for this project? So in sensor fusion, we just combine different type of sensors, and we just derive different type of data from different units, and we just try to get some information out of that data. So what's the use in this? We got different type of sensors, and like we got the motion sensor or the vibration sensor. Along with that, we got the environmental sensors. So with this, we are going to look for the four classifications actually. That is the pump on, the pump off, and the air inlet blocked and no air filter targets. So these are the four conditions we are going to predict through the data incoming through the sensors. And we are going to run this on this RSL10 device, which has very less amount of you can say like flash memory and like RAM, and not very big applications. Like the TinyML has opened a lot of opportunity of adding AI to all the small sensors. So I'm going to just brief you about what are the features, input features we are going into this project. So first of all, we have the motion sensors or the vibrational unit that is going to tell us the tilt and the placement of the pump, and the movement, actually shaky motions, vibrations. And this is going to be our main usage for the sensors. And We're going to combine this with TinyML, Neuton TinyML platform to build our TinyML model. So let's start this. The steps are as follows. You're going to need OnSemi IDE and SDK packages, and you're going to load all your example project. And this is the setup for the hardware we have used. And I can just show you just it's a bit tiny actually. Yeah, so I'm sorry if it is blurring out. So yeah, this is actually we are going to need our codes for printing this is the data collection step actually, and this is how it was done. The sensor was mounted on the pump itself, and the data was being gathered through the laptop, and this is how the data looks like actually. So this is how your data is going to look like. So we got 4 classes and we just collected lots of data. You can see the sample size of each class. So like they're near about more than 40,000 for each class. We collected this much data. So overall it was around 120,000 total data points. And now comes the second part, that is the model training. On the Neuton platform, you're going to train the model. These are the parameters we are going to use. We are going to use the metric as accuracy. And this one, we are going to use window auto size selection. So what is actually we are using is digital signal processing for our motion sensors. And once your training begins, you can see your features, data features, like you can see the what are the your data features which you got. That is automatically generated by Neuton. That's a very exciting thing. You don't need to chunk with your data. You don't need to play with your data so much, because the visualization is so good with the Neuton platform that it just gives you good overview of your data, what it is doing and how it is related to the output variable. And this is the heat map that is being generated by the platform itself. And yeah, now our training has finished, and you can see we got a good model accuracy with around 99%. So that's pretty good, and it can be used. And this is the confusion matrix, and it gives a big idea, or you can say the big picture, like how the model is going to perform on the machines. So once it's done, you're going to have a download button on your screen, and you're going to download the TinyML model. And if you see the size, we're going to see next the size of the model. It's very tiny actually. So once you're downloaded it, we are going to load it into our IDE. We're going to run our main code for that. And you can see we got the classes. The Neuton function is like we are feeding the inputs from the sensor, and there's a Neuton model function that is going to run the inference. And once the inference is run, you're going to get the classes or the output classes. So after flashing it, you should get this output. It means that your board is successfully flashed and it is ready to be running the model. And you can see the model is loaded successfully. Okay, the might not be very clear, but here it's model characteristics, and you can see the size of the model. Not even you're just utilizing a very minute fraction, a minute amount of memory on the board. So your board has ample amount of storage space, or ample amount of space for other applications. So this is how you can apply TinyML for such solutions. And interesting is your model size is very less, so that you don't have to be worried about your main applications. So how we are going to use it is how this is actually a data driven maintenance model. So it requires an evolution, although this is going to take some time. So what you are going to do after this project, so the main thing is you're going to start collecting some data and then feed into Neuton TinyML model, and that's all. You can deploy it on any hardware. I hope you enjoyed the project.
Thank you so much, Sumit. Now, just before we move on to any questions we may have, Sumit, I just want to remind everybody that if there is anything on the screen from the projects that is a little too hard to read because it seems too small, these are all projects that are published on the Electromaker website. And as we go through, we will make sure there are links to these projects in the chat. And of course, if you head to the project section of the Electromaker website, you will see the titles of each of these sections there. All of these projects are being read from there, so you'll get exactly what is being presented. And we do have a question for Sumit just now, which was, in the project, it says that the inference from Neuton is faster than any other existing TinyML solutions. What solutions are you comparing them to? Could you name a few?
Yeah, I just tried with TensorFlow Lite that was tested by me, but it was pretty much large and the inference time was actually huge. In this one, actually, we got very less, the prediction was pretty much faster and the model size was extremely slow. So yeah, it's better than TensorFlow Lite for MCUs.
Fantastic. All right. Well, thanks so much, Sumit. And as I mentioned, if there are any other questions for Sumit now or even later, feel free to drop them in the Q&A. They will all get answered, even if they don't actually get answered while we are live right now. But let's move on to our second speaker. You are about to hear from Leonardo Cavanuisa, and his project is called TinyML Slope Control for Robots with Arduino Pro. And just before we go on, let's watch a very short video of this in action. It was a very short video of it in action. But yes, in short, this is taking an already existing robot and giving it a little bit more control over its environment. Just before we go on, very quickly, Leonardo is a firmware engineer and a passionate one at that. As mentioned, he has a focus on the Internet of Things, but he also has a strong interest in embedded systems, firmware programming, FPGA programming, and all of that good stuff. And without any further ado, I'd like to hand the floor over to Leonardo.
Sorry, I can understand the question. I have to start with the presentation.
Yes, go ahead, Leonardo.
Okay, sorry for that. Okay, did you see my screen?
Not quite yet.
Okay.
Oh, it's just heading up now. Okay, perfect.
Did you see my screen now? Can you read me
Yes.
well? Okay. Now, do you see my screen?
Yep, it looks good.
Okay. Hi everyone. I'm Leonardo, an embedded software engineer with passion for IoT and electronics, and I'm also a brand ambassador for Neuton AI. In this presentation, I will explain how to create an inclination estimator system with Neuton, TinyML, and Arduino. The system built predicts the floor slope with the scope to help a vacuum robot in its operation. For example, estimating the slope, the robot can detect bad condition, like for example, starting over obstacle, or like for example, starting over obstacle like carpet, shoes, or other things in your home. In this way, the robot can change the trajectory according to the slope of the floor of the obstacle. The Arduino board in use is the Arduino Nicla SenseMe, a tiny and powerful Arduino board with 32-bit microcontroller. This board is equipped with a lot of sensors, and the slope estimation is based on accelerometer sensor. The accelerometer sensor mount on the board is the Bosch BHI260, a 6-axis inertial motion unit. Nicla is part of the Arduino Pro family. Arduino Pro is an IoT application platform developed by Arduino. But in this project, I don't use the Arduino IoT platform, but I use only the Arduino board. Okay, the goal of this model is to estimate the slope inside the range 0–5 degrees. I choose 5 degrees as maximum value because it's okay for this application, because is a steep climb for a robot, for a vacuum robot. This problem can be approached in two ways, with two methods, as a regression problem or as a multi-class problem. In the regression problem, the slope is output as a continuous value, like for example 4.56 degree, and in multi-class problem, the slope is expressed as with an integer value. Prediction, I choose to classify the prediction of multi-class problem in 6 classes. In order to output an integer value. The classes are from 0 to 5. Okay, the experiment is composed by 3 main stages. The first stage is capturing the training data set. The second one is training the model with Neuton AI. And the last is deploying the model on the NICLA board. Let's start with the first stage. For creating the training dataset, I realized a dedicated Arduino program able to acquire 50 accelerometer and 50 gyroscope value for each measurement. I performed 10 measurements for each class, and the total is 60 measurements in total. Okay. I choose a small data set in order to analyze the Neuton AI performance in a critical condition. As a slope reference, I used the Apple inclinometer app of my iPhone. Okay. For the training phase, I used the Neuton AI cloud platform. And I have created 2 solutions, one with the regression and the other with the multi-class classification problem. Training with Neuton is easy. Just uploading the dataset. I just upload the dataset and choose the task type. For the Neuton tool automatically detect, after uploading the training dataset, the Neuton tool automatically detects the task type. In fact, the tool proposed me 2 different task types, or regression or multi-classification. I choose both and I've created 2 projects. After the task type selection, I enable the TinyML option. And also I set the bit depth parameter to 32-bit, because the microcontroller used in the microcontroller installed in the NICLA board is a 32-bit microcontroller. Training process for both projects takes some minutes. At the end, the 2 models has reached a good level of prediction power. For the regression task, 0.3 RMSE, and for the multi-classification problem, an accuracy of 0.9 about. Neuton offers also, at the end of the training procedure, offers an extensive report to analyze the performance of the model. The platform calculates some metrics, as you can see in the slide, and plot them on a graph for better understanding. Also, the Neuton calculates an overall metric called model quality index that summarizes the result. In my experiment, both models reach a model quality of 19%. Very, very, very good. Okay, last but not least, deploying the model on NICLA. The output of the training process is a C library to download and include in the microcontroller application. The size of both library is very, very small, about 3 kilobytes, and deploying the model on NICLA is very easy. It's very easy, just 3 steps to follow. The first step is to include the Neuton library, just with the macro include Neuton point H. The second step is to create the input variable and populate the variable. and feed the model with the function Newton model set inputs. The last step is running the prediction with the function Newton model run inference. Okay, to validate the two models, I created two applications, one for the regression and one for the multi-class problem. Both applications output the result on the serial port of the Arduino. And the regression model, as explained before, outputs the result as a continuous value, while the multi-class model produces the result as a probability array. In each class there is the probability. The class with the measured probability is the candidate slope. At the end, as seen in the video, to see the model in action, I install the Mikla with a small lithium battery on my vacuum robot, and I realize an application that indicates the slope with LED color. Green if slope is below 4 degrees, and red if slope is over 4 degrees. I noticed that for my robot in my home, 4 degrees is a critical value, and sometimes my robot stacks on obstacle when the slope is over 4. Okay, that's all. Thanks for the attention.
Thank you so much, Leonardo, and thank you for your presentation. There was one question that showed up in the Q&A during this, and you did go some way towards answering it during your presentation. But the question is, which model is the best, the regression or the multi-class model to use for this solution?
In this solution, I noticed that the best model is the regression, but both models behave in a very good way. So, but in the last application, in the final application, I use the regression.
Fantastic. Well, thank you so much, Leonardo. And just another quick reminder that if there are any other questions, they will all get answered. You can ask questions to the people who are presenting this in the chat if you like. And also after the fact, we'll be keeping tab on all of these questions and make sure that they are passed on to the relevant people to make sure that they get answered. But just for now, let's move on to our next speaker. You are about to hear from Timothy Malcher, whose Smart Shipment with TinyML project takes the idea of tracking an object and takes it that little bit further. And we do also have a short video introduction for this one as well. So just before we go on, a little bit about Timothy. Timothy Malcher is working as an assistant professor at the Computer Application Department of Manipal University in Jaipur. He has 14 years of teaching experience, has earned bachelor's and master's degrees in computer applications and a PhD in computer science from Rabindranath Tagore University. His area of research is the Internet of Things, along with AI and ML, and of course computer vision, and in this case, TinyML. He is teaching computer science subjects like compiler design, database management systems, Python programming, data structures and algorithms, along with web programming. And without any further ado, I'll pass you over now to Timothy Malcher.
Thanks, Ian, for this nice introduction. And let me share my screen first. Okay, so I hope presentation is visible.
Yep, it looks clear from here.
Okay, so Ian has already given my introduction. So I will be discussing my project Smart Shipment with TinyML. So first, let us know a little bit about what is the project all about. So Smart Shipment basically is a project which can be implemented or used for the shipping industry. And this project allows us to track the status of shipment or package while the shipment or package is in transit. Okay, so this project is about tracking your shipment or packages. So with the help of this package, we can track the status of our package or shipment while it is in transit. And currently I have used 5 labels, but here are some labels that we can implement, and those are while it is moving or resting or stationary or impacted, thrown, picked, or it may be placed in wrong position. So these are some few status which we can implement, but it is not limited to it. It depends upon what you want to track. Okay, so why it is important? Why do we need to track a package? So we know that in our life we often receive packages and shipment, but we know that although there is an option to track our shipment or package in terms of its arrival to different cities or places or even the offices of the service providers, but there is no option to see the actual status of shipment on how it is being handled or treated. So this project is all about that. So why do we need this? Because it may be a simple case that user just want to keep track of its package, but in some cases it may also be possible that you want to track your package while it is in transit when it contains items that can break. So you must know that how your package is being handled. So this is the reason for this project can be used or implemented. So this project is basically based on Internet of Things and artificial intelligence. Obviously, we are using TinyML. So AI or the artificial intelligence allows us to track the status of package, and Internet of Things allows us to send the information about that particular status of package to the internet, which can be then further accessed via the web application. So this diagram on your screen, as you can see, shows that the data is published by the published on the cloud server over the internet and can be accessed via the web application. So the requirement to build this project, so you need a microcontroller, accelerometer, and gyroscope are the sensor. And for you, because your data is being sent or published on the internet, so you also need modules for communication. So in my project I have used Wi-Fi, but when you are actually implementing this project on the real for the real use case, then you would need something like NB-IoT or a LoRa network or GSM, because the Wi-Fi connectivity is not always available outdoor. And software to build this project, I have used Neuton AI platform to build the TinyML model, and Arduino IDE for developing the firmware, and Visual Studio Code for developing web application. And we also require MQTT broker. So because we are using MQTT broker, which receives the data from the device and publish it to the web application. So MCU, we can use there are variety of microcontrollers which are available. So here are some of the examples. You can use MCUs which has built-in accelerometer or gyroscope, such as this M5 stack, or you can also, or Arduino Nano 33 BLE sensors also there, which comes with these built-in sensors. But if you have budget constraint, then you can also go for Arduino Uno both. But when you are using Arduino Uno, so you need to have the those sensors additionally attached to this board, because this board does not come with the sensor. So there are a variety of other boards also available. I have just stated these few. So the MCU which I am using is MStack 5, and as you can see that it already has the built-in sensor which is needed for my project. And I am using accelerometer and gyroscope for my project. So as we are all aware that gyroscope is used for the measurement of the angular rotational velocity, and accelerometer can be used to measure linear acceleration. But when you combine these two, the accelerometer and the gyroscope, then it helps you in both rotation and the movement tracking. So that is the purpose of my project. So for that purpose, I am using accelerometer and gyroscope. And I'm also using MQTT protocol. So MQTT protocol is a very lightweight protocol, specially developed for machine-to-machine communication. And now it is widely being used on the internet. And it allows to send and receive data much more quicker way. So I prefer to use this protocol for my project. This protocol comes with the broker and the clients. So broker receives the information from a client, which is known as the publisher, and the other client, which is known as the subscriber, receives data from the broker. So broker here actually acts as a kind of a server. So TinyML, as we all know, that TinyML is the field of study in which we can develop machine learning models which can be executed on the resource constrained devices. So for my project, I'm using TinyML. Okay, and it has a lot of advantages also: low latency, low power consumption, low bandwidth, and privacy. So you can also build a tiny machine learning model using other tools such as TensorFlow. So here is an example when you are using TensorFlow. So the processor is a little bit longer. So first you need to acquire the data, then you have to design your model, and then you need to feed the data to that model in order to train your model, and then finally you have to quantize your model, or you have to make your model that can be fitted on the tiny resource constrained devices. And after that you can develop the firmware and upload it on the microcontroller. So these are the steps while you are using TensorFlow, but with Neuton it is more easier. You just need to acquire your data and feed in your data on the Neuton platform, and the rest, all the tasks from training to development of model and quantization, is done by the Neuton platform. And finally, you get the model as the library, C or C++ library, which you can use to develop firmware for the microcontroller. Okay, and for my project, I am using these five classes: stationary, moving, picked, wrong, and thrown. So these are some of the classes. And the first step is to collect the data. So I have collected data for the five classes, and here is the firmware which collects the data. So using this firmware, I have collected 12 samples, which is about 501 of rows of 10 seconds with 20 milliseconds delay for each label. So when you collect the data, so you have to prepare some CSV files for your data. So here are the 12 samples, and how you can collect your data. So it is recorded on the Electromaker website. The project is there, so you can see. So once you execute this firmware, which allows you to collect data, so once you run the firmware, you can see the information on the serial monitor. So you have to copy all these information, and you have to prepare samples like this. And finally, while you finish collecting data for all the classes, you need to prepare a final version of your CSV file in this form. So these are all the fields. So you have the accelerometer data as well as the gyroscope data, and you need to specify your target variable. So 0 is, for example, 0 is used for stationary, 1 is used for moving, and for picked for wrong position, and for thrown. So this is how you have to prepare your data. So once your data is prepared, you can now go to the Neuton TinyML platform, and these are the steps. So I'll just show you how you can create the project. So this, once you log into the Neuton platform, so you get this screen. I already have few projects, so you can see some projects here. So you first have to add the solution. So you can give a name to your solution. So I give name smart shipment, and you can specify description if you like, then click on next. So when you click on next, then in the next step, you have to select the file. So I have already uploaded my file which contains data for training. So here is the file which I have prepared. So I have already uploaded it. So once you upload it, so you can also access this from the platform. So you just need to choose, and then it will get your file, and just click OK. Then you have to you will get you need to select the target variable. Okay, and then click on next, and the training will automatically start. Okay, and your model will be built. Okay, so before the training is started, first we have to select the task type. So I have selected multi-classification because I am classifying 5 labels, 5 classes, and then you need to choose the TinyML. Okay, and rest you can leave it as it is, and you have to select the you just leave the rest of the second, you just leave it as default. And here I think I'm just forgetting some step. Okay, so you can click on start training, and once you start the training, once the training is completed, I already have this project here. So once the training is completed, you get all the information, and the C library is will be there for you. So you can just download. This is the quantized model, so you can download it. Okay, so you will get your library. So once you get your library, so you have to prepare one folder, and within that, this will be your main project folder, and within that you have to create src subfolder, and there you need to extract all the files, and then you have to create one Arduino source file, which is your main file containing your code. So in this file, you just need to include the library which you have created using the Neuton platform, and you also need to have include other libraries such as the MQTT library as well as the library for mstack5. Okay, I am using the MQTT broker Hive MQ, and this is an MQTT broker. So I'm using this. This is available free of cost for testing. So you need to specify some settings here, and then you need to specify the input variable. So I am using the accelerometer data and the gyroscope data from my sensor. So you need to specify the input variable also, and then you can call the Neuton underscore model run inference function, which executes your model, and the results you can get. So based on the results which you get, you can then check what is the target variable which the the model is returning, and then you can store it as a string value. You can specify a string value in a variable, because we will be sending these value to the MQTT server. Okay, so the model which I have prepared using in Neuton TinyML platform is relatively smaller than the model which I have developed using TensorFlow Lite. Okay, and this is the project workflow. So this is how you make the model. So shipment, you collect the data using the data collection firmware, and then feed the training data to the Neuton model, and it will give you the quantized model. And then that model you can use to prepare the smart shipment firmware. So this is the model building part, and then you can upload the data on the microcontroller, and the microcontroller, with the help of sensor, collect the live shipment data from the sensors, and it sends the information to MQTT broker. So the inferencing, this is the result of inferencing, which will be written in the form of string value. So these value will be sent to the MQTT broker, which will be further accessed by the web application. So this is how the overall project works. And then finally, the fourth step, you need to prepare the create the web application. Okay, so this is all about. So I would like to show one detailed video on how this project works. I hope you will enjoy it. Okay, so this is all about the project Smart Shipment. Thank you.
Thank you so much, Timothy. That's a fantastic project. I noticed as we were going through, there's actually a couple of questions. I think what we'll do, if I ask you one of these questions now, and then if you would like, you can answer the second question in the Q&A while our next speaker is talking. But the first question I got for you, you actually partially answered this question already, because the first part of the question is, can I embed this module to any MCU? And you mentioned, of course, that this can be deployed on various MCUs. But the specific question is, would this sketch work for Nicola Arduino? I'm assuming they mean the Arduino Nicola ME boards, the new Arduino Pro boards.
Yes, you can use Nicola Arduino board. You just need to change your code a little bit according to the libraries which are provided for the Nicola board.
Fantastic. Thank you so much, Timothy. We're going to move straight on now. We have another presentation for you, this time from Rushika Rajkumar. And this is an implementation of the popular Tic-tac-toe game, although it's using TinyML in order to do digit recognition on an M5 stack touchscreen. And before we go any further, let's watch a very short video of that in action. Okay, just before we go on any further, I just want to quickly introduce our next speaker. So Rukshika is an aspiring robots engineer who's currently an undergraduate student and also an amateur Arduino developer, an independent YouTube creator and a blogger. She's interested in robotics, 3D modeling and artificial intelligence and is always focused on developing technological solutions to real life problems. So without any further ado, I shall hand you over to Rukshika.
Thank you, Ian. Now let me share my screen. Okay. So today I'll be talking about the tic-tac-toe game with tiny ML-based digit recognition. So for this project, I have used the M5 Stack Core 2 IoT development kit and Neuton Tiny ML to train my model. So I have used Python to create this graphical user interface, and I used Tic-tac-toe to design the game. I've used Arduino to help me to collect my data as well as help my device to communicate with Python. So you'll be using handwritten digits, and these digits will be recognized with the help of TinyML techniques. And yeah, so let me give you a short introduction. So this game is also known as the X's and O's. So for those who are not sure, the player who places 3 of his marks in a vertical, horizontal, or diagonal row wins the game. So this is a 3x3 grid, and you can place your markers, which are the X's and O's. So to place your markers, you'll be needing the position numbers, which are going to be drawn by you on your M5 Stack Core 2 device. So this is a 2-player game, so you'll be needing someone to play with you. And each player will be taking turns. So if the player with X goes first, the next player will have an O. So for this one, yeah, here you can see how the 3x3 grid is designed. So if you want to place your X or O on the top right corner of this 3x3 grid, you can draw a 3 on your M5 stack, and your marker will be placed accordingly. And the next part is what inspired me to do this project. So I was inspired by the MNIST dataset, which is a dataset with hand-drawn digits. So this has 0 to 9. And it has a lot of data, but I wanted to use it for my device. So I tried to recreate it. And this time I was having samples for 1 to 9. And they are programmed according to the M5 stack. So each screen has a specific resolution, and the position number, not position number, it's actually like the location number of your pixel is calculated using the screen resolution. So it can differ between different devices. So I wanted to recreate this with my M5 stack. And the first step was the data collection. And for data collection, I used my M5 stack and Arduino. So I used the buffer method to store my data. And I collected a total of 1,800 samples. And 75% of those samples were allocated as the training data set, while the remaining 25% was allocated as a test data set. So in this case, I was having 1,350 samples for training, and another 450 samples for the testing. So that's like 150 samples of each digit for training and 50 samples of each digit for testing. So the data is equally distributed among each digits. And this is how I was using to calculate the pixel location. So right after your data collection is done, you'll be training your model. So in this case, I wanted to make my model more accurate, and people can have different handwriting. So and they have different methods of writing a specific number. For example, 7 could be written like this, and also like this. So there are different methods. So I trained my model to recognize each of these digits accordingly. and I made my samples more diverse. And then Neuton TinyML requires your datasets to be in the CSV format, so I had to prepare my training and test datasets as CSV files. So to train your model, you'll be needing the Neuton TinyML, and don't worry, it's a no-code platform, and it's pretty simple. So this is how you can create your solution. So you can go to add new solution, and you'll be creating a solution like this. And then you'll have to upload your data set, and your data set needs to meet certain requirements before it can be accepted. But it's pretty simple. It just has like a minimum number of requirements, like the minimum number of columns, the minimum number of rows, something like that. And you should not have duplicated your data, or there shouldn't be missing values. So it's something like that. You can always find them in the user guide. And first, as soon as you upload your data set, it will undergo data validation. And once it's fit to be trained, you'll be seeing a green tick, something like this. And then you can click on OK and proceed to the next step. And here you'll be asked to select your target variables. So the target variable is the one which you're going to predict. So in this case, I want to predict the number. So for this one, I've selected the target variable as label. And automatically all the other variables are chosen as the features. So the features are going to assist your model to predict the label accordingly. And then once it's done, it will be asked to choose a few parameters. So this is pretty simple. And then the task type is multi-classification, because my model is going to be predicting samples from 1 to 9. So it's going to classify them. And then you have to choose unified scale for all features, because all the values are within a specific range. So all of them are having in a same range. So you have to normalize them. And then you can start training, and the process does not take long. And then once it's done, I had an accuracy of 87.5%, but this can be improved with more data. And then also, although I had an average accuracy, I'm pretty satisfied with my results because it worked properly. And then this is how it looks like. And this is the confusion matrix. So the confusion matrix actually shows how well your model is performing. So it shows the actual class against the predicted class. And you can see it's something like a visual interpretation of how your model is working. And then we have the correlation heat map that shows the correlation between different variables of your data. And then we have the data overview. So as you can see, all the 255 the data was a float variable. And then you can see that the data is equally distributed. And then we move to the next step, which is the prediction. So I had to enable prediction to see how well my model performed. So you have to collect another set of data. That's for the data set, testing data set. So I mentioned this earlier. The prediction process doesn't take very long. It only takes within a few minutes, or 2 or 3 hours, depending on how much data you input. And then the results were better than expected. So when I thought my model had an accuracy of 37.5%, I was afraid that it would perform bad. But the results were beyond my expectations. And then you can download the C library directly. So this C library helps you to embed your model onto your M5 stack. So it also has a README file where you can read the instructions of how you can actually embed your model. So the next step was to embed the model in M5 stack, and this is how it was done. So it's really simple. You can always find the full code in this project. So I hope Ian would have send this link in the chat, so you can always view it and find the whole code. The next part will be developing the game, and we'll be using Python for this. So the Tic-tac-toe is a standard GUI library. And with that, I was able to create a not a perfect, but a better GUI interface for the user to play this tic-tac-toe game. And you also need Python to help your device to interact with your computer. So it's something like a human-computer interaction, and this is possible with Python. And there are 5 components of this Python application. So the first part is to create the splash screen. So this is where you can find the instructions, or you can head towards the game directly. So for those who don't know how to play the game, you can click on instructions and the instruction page will pop up for you. So here you can see how you can play the game. And when you're ready, you can click on the play button, and it will open the game.py file. So here, when you first open this, the place button is initially disabled. So you cannot place your marker unless you draw your position number. So when you click on ready, your device will be ready to accept inputs, and you can draw your position number over there. And once your input is received, you can see that the place button is automatically enabled. So you can click on that button, and your marker will be placed on the position number which you specified. And once it's done, you can automatically see this button will be disabled and this button will be enabled. So the process is something like that. If you want to quit this game midway, you can always click on this exit button, and this exit button will show you an error message, or a warning message. Actually, will show you a warning message if you're ready to quit the game. And if you are ready, you can click on yes, and the game, the window will just close by itself. Then the next part is what happens when you win the game, or what happens when the game is over. So this is how it will look like when player 1 wins the game, and this is how it will look like when player 2 wins the game. And this happens when it's a draw. So if I had not specified earlier, player 1 is the cross and player 2 is the not. Yes, so this is how my project works. So the code and the description of this project is available in Electromaker page. And you can always visit this page to see more about this project. So I hope you like this project, and yeah, thank you.
Thank you so much, Ruchika. That was fantastic. There was one question for you, but what I'm going to do is I'm going to put that into the text chat just because just to make sure everything keeps running along in time. I'll let you answer that one by typing while our next presentation is ongoing. And with that said, let's move on to our final presentation of the webinar. I'm about to hand you over to Leonardo Gonçalves, who is going to be teaching you how you can predict the champion of the next F1 driving race using TinyML. Before we do, there's a very, very quick video of this thing in action. And before I hand you over to Leonardo, just very quickly, he'll be able to explain what you were looking at in that video. Leonardo has more than 6 years experience as an IoT product developer with complex connectivity projects and businesses at the forte. He is an accomplished goal-oriented technology solution. I'm not managing to read this right now. He is an embedded firmware development leader and passionate about the power of the Internet of Things in the way it can transform traditional businesses, and he is constantly learning. And with that said, I'm going to pass you over now to Leonardo Gonçalves.
Thank you, Ian. Let me share my screen here. Can you see?
Yep, that looks good.
The project at the Electromaker.
Mm-hmm.
Yeah, okay. So I decided to make a project to show the power of TinyML on motorsports. For this example, and in a Formula One car. So I have decided to make a project that everyone can run on your own home with simple IDEs and simple boards. So I have used the Arduino Nano 33 BLE Sense board. That's a very common board available on the market, and these platforms, these IDEs. So I have used the Visual Studio Code. That is the most usable IDEs by the developers, and the Platform EU. That's a collaborative platform to build projects for different boards of different vendors. It has a user-friendly interface that you can debug your project using different boards. And I have used Neuton platform to create my model and to build my model in order to embed it on my microcontroller. That is the Arduino Nano 33 BLE Sense board. That's it. So I have always been fascinated by Formula One. Unfortunately, today we don't have a Brazilian driver on it, but I keep watching it. So I have made this project to be simple, only to show the power of TinyML on predicting things on sports. So I have mounted the board on a miniature car, as you can see here on my video. I have mounted here and the Formula One miniature car in order to predict which is the fastest car between the others. So this project has three main steps, three simple steps. That is collect the data for the data set to train the model. That's the second step. And after the model was trained, we will deploy the model on the microcontroller to predict which is the fastest. And we can predict a lot of things because Formula One car, as everyone knows, has 100 and 1,000 of sensors. So you can use a project like this to predict a lot of things. So let me show how I collect the data. To create a machine learning model, you need to have data on your hands to predict what you want. So in this case, I am using the accelerometer data to predict which is the fastest car between these three. I know that Williams today is the worst car and Ferrari is the best. So I have made 4 targets. When car is idle, when the car is stopped, it's not moving. My second target is when it's Ferrari, that when it's running very fast. The second, the next target is when it's a Haas car. It's an intermediate speed. And the last target is when the car is Williams. That's very slow. Let me say that. So I have developed a firmware that collect the data from the accelerometer and collect a lot of mathematical statistics from the sensor. Here, the minimum, the maximum value, the average, the variance, the standard deviation, and in X, Y, and Z axis from the accelerometer. So the firmware that I have developed here is available at GitHub, so everyone can clone it and build it using Visual Studio Code and Platform EU very, very easily. And you can upload it to your board if you have. So it's very simple to clone and run it. After you collect your data, you need to copy it. You can use these firmwares, collect the data and print it via serial interface. So you can use PuTTY or Doclite software to see the data and copy and paste it in a CSV file to upload it to Neuton platform. I think other people has show how you can upload your data. So I will skip this step. It's very easy. Neuton has a very friendly, user-friendly platform, so it's very easy to upload your data. And for this kind of problem, it's a multi-classification problem because we are predicting which is the car. So if it's the fastest or if it's the slowest car. Let's go. After you train your model, Neuton will give you the metrics. So in this case, the metrics are very good. It's 100% of accuracy. So here are the other coefficients of your model. So we are using very low RAM and very low flash to build this model, to use this model, and the inference time is about lesser than 1 millisecond. So it's very fast also. So you can on Neuton platform download your the C library to deploy it on microcontroller. And after you deploy, you need to input your data and run the inference model provided by Neuton, by the Neuton library. So here we are predicting the Idol, the Ferrari, the Haas, and the Williams car. All the available code, it's also available at GitHub. You can download without, you don't need to train your model if you don't want. You can download the trained model here and compile and run it on your board very easily, as we are using very common IDEs and frameworks. So to test your model, you can fix your board in a car or in an object and simulate different speeds. So you can see the model running when the object is idle, when the object is very slow, when the object is in intermediate speed, and when the object is in a very high speed. So that's it. The training data set is available here for download at the Electromaker site, and the two firmwares, the two projects are available also for anyone who wants to run this example on your home. So that's it. Thank you. Hope you like.
Thank you so much, Leonardo, and thank you to all of our attendees here, and also everyone who's just given a presentation. They've all been fantastic. Now is the time to decide on who you, the attendees, think is the better of all of these projects. We're about to have a little bit of an award ceremony, but it's not just going to be an award ceremony for the people who've given you presentations. There's also going to be some giveaways for the attendees. So, Julia, is that poll now in action?
Yeah, I'm going to run it right now. And
lovely.
Please pay your attention and let's choose the best project of today. Now you can see on your screen 5 projects presented, and you can vote and give your vote for the best one that you like most.
So while this poll is going on, one of the things I also wanted to mention is, as well as there being an overall winner from the people who've given the presentations, everyone that you spoke to today will be receiving some things from Pact, who is one of the sponsors of this Maker Day. And I'll go through that just quickly now while the poll is still running. If that's okay with you, Julia, is that now a good time to do that?
Yeah, please go.
Super, okay. So, let's just see here. So there are various awards, and all of our speakers have been given various awards titles. And so first, we have Leonardo Cavagni, and he is the Lord of Smart Robots, and he will be winning the first book, which is Architecting High-Performance Embedded Systems, Design and Build High-Performance Real-Time Digital Systems Based on FPGAs and Custom Circuits. And this is a book by Jim Ledin. Our second one is Leonardo Gonzalez, which is Mr. Fast and Furious AI, which I think is a fantastic name for a prize. And he will be winning the book titled Designing Production Grade and Large Scale IoT Solutions by Mohammed Abdelaziz. And The third book we will be giving away is to Sumit Kumar, who is the Sir of Industrial AI, and he will be winning the book Architecting High-Performance Embedded Systems, Design and Build High-Performance Real-Time Digital Systems Based on FPGAs. This is the same book as Leonardo won, Jim Ledin. Timothy Malcher is the master of smart shipment, and his book will be Designing Product-Grade and Large-Scale IoT Solutions by Mohammed Abdelaziz. And Rukshika is the queen of X's and O's, who will also be winning the same book from Jim Ledin, Architecting High-Performance Embedded Systems. So these are the books that your speakers will be winning, but now we should, I think, have an overall winner. And I'd like to introduce to you Stefano Imlecito, who is the marketing manager of Arduino, in order to give that book away, that prize away.
Actually, we have 8 people who didn't vote yet. So Stefano, please start, and I will ask, please complete your pool and vote. Meanwhile, Stefano can start and say something about your new products, about the prices, please.
Yeah, so first of all, thanks for having me. It's a pleasure to be here and to see such a talented pool of creative people, and I really enjoyed listening to your project. So thank you also for choosing our software and hardware. We're really proud to be able to support you in this way, because as you know, at Arduino, we strive to provide creative solutions to everyday challenges. And I'm actually calling you from the Italian office of Arduino. So behind me, that's where our products are being invented. And then we still make them in Italy. So it's fascinating for us how the people that comes from the STEAM programs in school worldwide are deploying these solutions also in their businesses. So industrial automation, equipment, robotics, among of the technologies you are using today are still available pool of use cases we're receiving from many customers from many industries. So with regards to future products, you will see lots of great news this year as well. And as you saw in the last year, we are still introducing many innovations like the Niklas SME you saw, which is actually an Arduino Pro product, but it's being deployed from many makers and inventors like you. So I'm sorry, we will just have to decide one winner among you, because I believe you all deserve something. So I'm glad to understand from Ian and Julia, you are actually receiving a prize, each one of you.
Yeah, we have a surprise here, because we will have 2 winners, because also from our team, from Neuton team, we made our internal, choose, and it will be a second prize also for a project that we like more. But now we still have some people who didn't vote. Please complete it, because we really want to know who is the winner of today. Please, I give you 1 or 2 minutes maybe, and Stefano, if you can just say a few words, what will be prizes for today?
Yeah, so today we will assign a Portente H7 Lite, which is a very powerful product. I'm sure most of you already know it, and we believe it will help you and support you in your future projects. So looking forward to know who's the person that I will be sending that.
Okay, so let's start cut down. 3, 2, 1, and I will stop the poll. Who is gonna to vote? Please do it right now. You have only maybe 5 seconds to give and to vote for your for project that you like more. Okay, 3, 2, 1. I stop the poll. Okay, and the winner of today is Sumit Kumar. Okay, I think you can see. I don't know. I can share your the results here. You can see on your screen. Yeah, and the winner is Sumit.
Yeah,
congratulations, Sumit. Nicely done.
Yeah, thanks a lot, everyone.
Congratulations.
Yeah, congratulations also from our team. Thank you so much. But as I said, we have also our own winner from that we choose by Neuton team. And today is Timothy Malche. Thank
Congratulations.
you. Thank you so much. And you will receive Nikla. Stefano will help us with the shipment, right?
Absolutely.
Yeah, great. And now I think it's a start for the new challenge that we would like to announce. So the first part was to share with us your ideas, but our challenge has a name from idea to solution. So we need to see your solutions, the final solutions deployed and developed. So from today, we start this challenge. I will share right now the Slack channel we created specially for this channel, and we will share with you requirements and deadlines when you should submit it. Easily speaking, it's till the 1st of September. So we understand that summertime, maybe you have some vacations or wherever. So we give you time to develop it and develop it good and well, and also to start with a Neuton platform for your project. So you have time. We will be supporting you in this Slack channel. So don't hesitate to ask our technical team if you have some questions during the process. Our ambassadors, Leonardo, Timothy, Rushika, they can confirm you that we are always very open to help you. It's also our passion, so be free and just do it. And after 1st September, we will get all projects submitted. Until the 9th of September, we will choose the winner, and the winner will receive, Stefano, help me.
Another portento.
Yeah. Exactly. Okay. Now I'm sharing the link to Slack channel. Please join. In case you cannot to copy it right now, don't be worried. We will send you emails with all information and the link to join our Slack. Please submit your projects on Electromaker platform. You just need to make a note that this project done with Neuton platform and one of the Arduino board. Yeah, this is also important. So you need to use one of the Arduino board, whatever you prefer. It's up to you, and just put it in the description of the project, so we will know that this project is the one of the projects for this challenge. I think everything that we planned for today we did. Maybe more questions from you guys. I think we have couple of minutes to answer them. If you have some questions, please, it's your time. You can put it in Q&A, in chat, and ask us whatever you want.
While you're adding your questions to the chat for the last couple of minutes of this webinar, just to close it out as well as the competition that Julia has just announced. And as she mentioned, one of the things that is very important from our perspective is when you do put your projects on the Electromaker website, please make sure that you mention both Arduino and Neuton in the title of the project. It will just make it a lot easier for us to see them. We do also have some prizes to give away right now to our attendees. Before this webinar when this webinar was announced, there was an online form which basically just said, pitch us some ideas for what you think you could do with the Neuton TinyML platform. And we have actually got 4 winners of packed books for that project. So just quickly now, there are 2 books that we're going to be giving away. But the first 3 winners, that is Albert Ong with his Emotional Heart project. The second is Rahul Khanna with the Cough Recognition for COVID-19 project. And the third is Zwangsjwe Bay with the Cooperative Perception for Vehicle Infrastructure Nodes. Those first three will be winning the book that we've already mentioned once today, the Designing Production Grade and Large-Scale IoT Solutions by Mohammed Abdelaziz, provided by Pact. And the fourth winner is Robin Thomas with his project of digital stethoscopes providing heartbeat insights, and he will be winning the book Architecting High-Performance Embedded Systems by Jim Ledin. Unless there are any further questions, Julia, that we want to answer right now, I can start to bring things to a close. Of course, as Julia mentioned, everything will be linked to you afterwards. If there's anything you would like to see in terms of the project or the Slack channel to join for our Arduino competition, of course, you'll be able to find that. But is there anything else to add now, Julia?
Maybe I would like just to add that we have an ambassador program. So guys, if you want to join it, please be free with your projects. If you want to also participate in webinars and give a speech and teach others and share your knowledge with the community members, you are very welcome to do it. And we here from Neuton will help you with this. So please join us. I will be sharing also information about how to do it and how to apply for this program. Please participate in this challenge. A part of the prizes, of course, the Arduino and books and everything. Of course, you will learn a lot, you will achieve a lot, and you will be with us. You will have new friends and networking. So please join our community. I will be very happy to see you inside.
All right, well, thank you so much, Julia. Thank you for the opportunity to host this webinar. I've very much enjoyed it. And I'd like to thank every single one of the people who have spoken to you. Thank you to the attendees for attending. Thank you so much, Stefano, for being here to give away the prizes. And yes, as mentioned, if you would like to win this Arduino Portenta H7, you will be needing to use the Neuton platform, and you need to put those up on the Electromaker website as a project. These are all free things to log in to, and you'll be given links to all of those things. And yeah, thank you so much for attending, everybody. This has been a lot of fun.
Thank you, Jan. Actually, it was a lot of fun thanks to you.
Well, it's been a pleasure to do it, and I look forward to doing a lot more things like this in the future. So yeah, this has been absolutely fantastic. Thanks.
Thank you, and see you next time. I hope we will do second edition if you like it, guys. Thank you.
Absolutely, yeah.
Take care.
Bye bye.
Thank you. Bye bye.
Take care, everyone.
Bye bye.